Let's take a look at the next two questions. The directions ask us to write the slope-intercept form of the equation of each line given the slope and y-intercept. Now remember, slope-intercept form of an equation is y equals mx plus b, where m is our slope and b is our y-intercept. A lot of people get that confused sometimes with the slope equation, the y2 minus y1 over x2 minus x1. That's the equation just for slope, to find out what m is, not the equation of slope-intercept form. So again, we need y equals mx plus b. And in 11-12, it's actually quite easy because they give us the slope and the y-intercept. Right? There's no calculation needed. So I guess for 11, I can just write y equals, so the slope, m, comes next. That's negative 3 over 2. X plus, well, the y-intercept comes next. That's just 1. So 11 is y equals negative 3/2 x plus 1. Go ahead, pause the video, and try number 12. The answers will be up on the screen in 3, 2, 1, and here they are. You may have put y equals 4/5 x plus 0 as your equation. However, we really don't need that plus 0. It doesn't change the value of the equation. It's not technically wrong, but we really don't need it in that equation. The next two problems ask us to write the slope-intercept form of the equation, okay, so same as before, of the line through the given point with the given slope. Okay, so we're halfway there this time. They give us a slope, in the case of 13 it's negative 5, but they don't give us the y-intercept, so we're going to have to figure that out. Well, let's start by writing out the equation as best we know. So y equals, we know the slope is negative 5, x plus, now we don't know what the y-intercept is, right? They don't tell us, so I'll just write plus b for now. Now you might say that, oh, the y-intercept is going to be 2 because we have this point in here. But that's not the y-intercept. Remember, the y-intercept is where on the graph x equals 0 and y equals some number, right? It's on this y-axis. So if we had a point like 0, 2, that would be our y-intercept, right? But unfortunately, that's not what they gave us. They gave us the point negative 1, 2. So we can't just think that's our y-intercept. Instead, what we're going to do is we're going to use this x value and this y value and substitute those into the equation to solve for our y-intercept. So, let's see, x, a point on this line, has an x value of negative 1 and a y value of 2. So we're going to substitute negative 1 in for x and 2 in for y, and bring that right down. And now we can go ahead and solve this equation to figure out what our y-intercept is going to be. So negative 5 times negative 1 is positive 5. Okay, bring down that plus b, and then I have to subtract 5 from both sides of my equation. End up with negative 3 equals b. Yeah, negative 3 equals b, which means the y-intercept is going to be negative 3. And so the equation of my line will be y equals negative 5x minus 3. There it is right there. That's the equation of my line. I'm pulling that directly from up here, my original equation. And now that I know what the y-intercept is, I just fill it in, negative 3. Before I let you go on to 14, I want to show you what's going on in number 13 visually. We've done it algebraically, but let's look at it visually for a second. So here we are on the online graphing calculator Desmos, and I'm going to input as much of the equation as we knew at the beginning. So we knew that the slope should have been negative 5, so I'll have y equals negative 5x, but we didn't know the y-intercept. So I'll just write plus b. I'll add a little slider, and so if you move the slider around for b, for our y-intercept, you can see we have a line with a pretty steep negative slope, slope of negative 5, but we don't know what the y-intercept is. We don't know where the line is going to pass through the y-intercept. But we did know that it should go through the line, or it should go through the point negative 1, 2. Okay, and that point is right here in red. So if I take my y-intercept and kind of change it so that it goes through this point right here, oh look, my y-intercept has to be negative 3. And so if I draw another line, y equals negative 5x minus 3, and delete that old one, we can now tell that, hey, the line y equals negative 5x minus 3 has a slope of negative 5, and it hits or passes through this point negative 1, 2. So just to recap, we started by writing the equation, or as much of it as we could, with the slope but not the y-intercept. Then we took the x and the y coordinates, and substituted those in to our equation, solved to figure out what our y-intercept should have been, -3, and so we ended up with the equation y equals -5x minus 3. We also verified that using an online graphing calculator. All right, at this point, pause the video and try number 14. The answers will be up in 3, 2, make sure you've actually paused this and worked through it as much as you can, and here's the answer. And so you hopefully should have gotten y equals -2x minus 1. I mean, the -2 part is pretty simple. We're getting that from the slope. But the -1, you should have set it up just like we did in 13, where you have y equals -2x plus b. You substitute in your -3 and your 5 for your x and your y values. You solve, and hopefully you would have found that the y-intercept is, in fact, -1. All right, last two problems. Write the slope-intercept form of the equation of the line through the given points. Well, slope-intercept, we're still working with y equals mx plus b, but now they haven't given us the slope and they haven't given us the y-intercept. So we're going to need to find both of them before we can continue. So what's easier to find first, the slope or the y-intercept? Well, probably the slope. Think back to problems 1, 2, 3, and 4, where you found slope between 2 points. We could do it then, wasn't that bad, and we can do it now in problems 15 and 16. Slope between them. I like using the change in y over change in x method, so that's what I will use. So the change in y from -4 to 0, looks like you'd have to increase by 4 for that. So my slope is going to be, let's see, it's going to be +4, so 4. My change in x from 3 to -3, looks like you're decreasing by 6 for that, so -6. And if I had to simplify that slope, 4 and -6, they could both be divided by 2. So we'll have 2 over 3, and a positive divided by negative is a negative, so a slope of -2/3. All right, so now I know that my equation should be y equals -2/3 x plus, well, we still don't know what the y-intercept is, so plus b. But we can use the same method we used in questions 13 and 14 to figure out what that b is, what the y-intercept is. So just pick either of these 2 points. I'm going to use this one right here, this 3, -4, and substitute that in for x and for y. I mean, after all, this point is on the line we're trying to find, and so it makes sense that I could substitute those values in. So let's see. 3 is my x value. -4 is my y value. So I can write -4 equals -2/3 times 3 plus b. Now, remember when we're multiplying fractions together, we can always put 3 as 3 over 1, multiply the numerators. So -2 times 3 is -6. 3 times 1 is 3. Bring everything else down. -6 over 3 is just -2. Okay. And now this has actually gotten quite simple to solve, right? It's just a one-step equation now. Add 2 to both sides, and we're left with -2 equals b. So in that case, if -2 equals b, now I've got my y-intercept, and I've got my slope, right? So I can write the equation, y equals -2/3 x minus 2, and that is the equation of my line. Before we move on to 16, let's just make sure we know what's going on visually in 15. Again, we're back to the graphing calculator Desmos, and in the beginning of this problem, I had no idea what the slope was or what the y-intercept was. So I'm going to write y equals mx plus b and get sliders for all of them, right? I didn't know what the slope was, positive, negative, I didn't know, and I didn't even know what the y-intercept was, right? Where it's supposed to cross the y-axis. But what did I know? I knew that my line has to pass through the points, what was it, 3, -4, and -3, 0. Right there, those 2 points right there in black, and and red on our graph. And so now if I try and move this around a little bit, try and get that slope right, okay, and move my y-intercept around a little bit, I bet I can get this to line up. Well, okay, -2 looks pretty good for a y-intercept. Let's see if I can just put in -2/3. Oh, hey, look at that, right? If I put in -2/3 for a slope, and if I put in -2 for a y-intercept, look at this green line. It passes right through those 2 points, that -3, 0, and that 3, -4 point that I had before, right? Got the y-intercept right there of -2. So it turns out that that makes sense. When I have the slope of -2/3 and a y-intercept of -2, then the line passes through the 2 points that they specified. So just to recap, in order to do 15 and 16, first I found the slope. So find the slope first, and then I found the y-intercept just by substituting in those points for x and y in that equation. So at this point, pause the video. Try 16. Make sure you're pausing, and the answers will be up in 3, 2. Here are those answers. All right, there it is. Y equals -1/2x plus 3. If you forget how to do it, remember, step 1 is to find the slope. Find the slope between those 2 points. Step 2 is then to pick either of these 2 points and find the y-intercept by substituting in those values for x and y. And as a little hint, I would probably substitute in this number for x and y, just because it's got a 0 in it, and multiplying by 0 is kind of straightforward, pretty easy. I mean, you could use either of them will work, but it'll be a little easier to use that one. All right, we've reached the end of this video. Hopefully you've gotten a good refresher on some graphing techniques from Algebra 1, and I will see you in class.